Swayam Prabha. Digital India. Educated India.
I am Dr. Rajiv Mishra, working as professor in the Department of Computer Science and Engineering at Indian Institute of Technology, Patna. The title of this lecture is AI for Edge and Edge for AI. Now, preface, in this lecture we will discuss the following topics under this particular theme. That is, we are going to discuss about the issues which is going to be there in traditional IoT platform, that is Internet of Things platform, how the Edge ML addresses the issues of such IoT platform, what are the workflows of edge machine learning and the advantage and applications of edge machine learning. Then we will discuss about the intelligence at the edge. We will also consider in that perspective the deep learning at the edge. Then we are going to discuss the deep learning models at the edge and their optimizations. Then we are discussing about the segmentation of deep learning models in the edge, and then visualizing the edge, deep learning, distributed deep learning training and collaborative edge training, and computation offloading modes of edge and edge caching. Now, let us recapitulate what do we mean by Internet of Things. Internet of Things is a network of internet connected devices, they are called as IoT devices, embedded in everyday objects, enabling sending and receiving data such as setting and telemetry. So, again let us revisit the definition of Internet of Things is also called as IoT. Internet of Things is a network of such IoT devices which are embedded in everyday objects, enabling sending and receiving data such as setting and telemetry. For example, here these are the objects, they are called self driving car or a mobile phone, or let us say a mobile phone is moving, then you can see this is the garden embedded with the sensors or IoT in it. Here also the IoT is there embedded in this particular system, and this is the IoT in the industrial use case. So, these Internet of Things devices which are embedded in these objects, IoT devices embedded in the objects, thereby enabling these objects for sending and receiving the data such as the settings or telemetry. So, the important protocol which does this sending and receiving is called MQTT. MQ stands for message queue and TT means telemetry transport. So, this is all about the Internet of Things devices. Now, when you say that they are sending and receiving the data, where they are going to send, which is shown over here, it is the cloud and edge system. Therefore, these internet connected devices, they are called IoT devices, is a network of internet connected devices which are embedded in these objects. and enabling this particular technology which is called Internet of Things for sending and receiving the data such as the settings and telemetry which will be there. Sometimes this is also called a machine to machine communication, machine to machine communication, and this often uses a particular protocol called MQTT. So, these two ends here at all the places they will be communicating with each other without any manual intervention, and this particular thing is called machine to machine communication or M2M. And for that they are using a protocol which is called MQTT, message queue telemetry transport. Now, let us see that what is the traditional IoT platform. Traditional IoT platform that we have seen in the previous slide, that IoT devices with the help of the machine to machine communication, that is MQTT, directly sending the data and receiving the data from cloud. So, this is more detailed viewpoint of the same traditional IoT platform. Here Internet of Things, also we call it as things. So, they are often communicating the data and receiving the data. Let us understand what they are communicating and what kind of data they are receiving. So, this can be shown in this IoT platform, that once this edge devices is connected to the service provider, that is Azure IoT Hub for example, different custom modules are there. So, this particular module which is running inside the cloud, which is shown over here. So, that part of the cloud service which will accept the data through the cloud gateway. Let us assume that the incoming data that is given for the custom vision module which is running here as a part of Azure IoT Hub, and another one to manage and control and get the score display of the module, and the last one is called custom vision module. So, let us understand over here. So, these things, when they send the data with the help of a cloud gateway, then this particular data will be analyzed, and this analysis is called getting the insights of an IoT data. So, getting insights of an IoT data requires some machine learning algorithm to be running on the cloud side, and when it gets an IoT data, it gives the insight which is present inside an IoT data. So, insight present inside the IoT data will be uncovered, and then this particular insight will give the actions to be taken. So, what action to be taken? This will be communicated as a result again back to the thing. Here it will be the sensor data which it is sending, and here there will be an actuator. When it gets the response, the actuator will take a particular action. For example, that if let us say that in a garden, if let us say there is a water sprinkle. So, here let us say that there are IoT sensors embedded, and when this IoT sensors send their data, that is temperature and all that environment, dryness of the soil, when it is sent to the cloud, then the cloud will give the after the insight, it will take the action, and that action will be to sprinkle the water. So, water will be spreaded around this area, sprinkle the water in a garden, often seen as actuator getting the response from the cloud based on insight in the IoT data. So, that is why running this machine learning model for getting the insights, the data from an IoT need to be sent in the IoT platform. So, what is the drawback? Drawback of traditional IoT platform. So, the drawback of the traditional IoT platform is that IoT is sending directly to the cloud for getting the insights of an IoT data, that is the sensor data, and it computes an action, and that action is again communicated back. So, this particular time is called round trip time. So, the drawback is the round trip time is requiring not only the time, that is called delay, but also it incurs lot of bandwidth to send the IoT data to the cloud. It is not only one IoT, but billions of devices. If they are sending their data to the cloud, this particular bandwidth requirement will be quite heavy and costly also. So, traditional IoT platform, we have seen the drawbacks and these limitations of the traditional IoT platform will also affect from certain things. Let us understand that situations, the poor internet connection, if the let us say the internet is down, the system fails in that case. For example, that smart fire alarm system having the IoT sensor connected with the cloud will not be able to operate if there is no internet connection, because it is not able to send the data and compute the insights and get the results back. The other important limitation of traditional IoT system is data gravity, that is IoT devices create lots of data that demand more ways to find insights locally on the device than shipping all the data to the cloud. So, sending the data to the cloud is called sometimes becomes unnecessary and also leads to the data gravity. So, for example, smart doorbell, if you do not want to stream the videos to the cloud 24/7, then it has to just identify the faces for 2 minutes that someone is in the front of your door, and you would rather do that locally on the smart doorbell. Similarly, as far as the real time responses are not there, as opposed to the near real time responses that you cannot get by sending the data to the cloud because of round trip time, which we have explained, that is nothing but the delay involved in sending the data to the cloud and computing it to find the insights and then sending the actions back down. So, that required sometimes a real time responses, but the delays are quite more. And so, let us see that machine learning on the cloud versus machine learning on the edge. So, the traditional drawback is that the machine learning was happening in the cloud, and because of that the IoT devices are communicating their data directly to the cloud. So, it is an IoT cloud platform which was working, that is called traditional IoT system, and it was having the drawback which we have stated in the previous slides. But it enables the remote monitoring and control applications, managing the data across multiple IoT devices and near infinite storage to train machine learning models and other advanced machine learning models. These are some of the use cases which was happening in the traditional IoT platform. Now, let us see that if we improve with the help of edge. So, therefore, between an IoT there exists a layer which is called an edge, and then edge will then communicate with the cloud. So, this particular addition of a layer which is called edge layer if this edge layer is equipped with the capabilities of a cloud like services or it mimics the cloud like services, then IoT data has to send up to the edge and get the result back. Therefore, the long haul communication, that is long haul communication to the cloud, can be avoided, and also not all data of an IoT data, not all an IoT data needs to be sent to the cloud. So, let us understand what kind of functionality is required here to save all that, and this particular functionality is called doing machine learning on the edge. So, the edge enables the machine learning to run on the edge, then the IoT data need not to send to the cloud, and this particular fact is called doing machine learning on the edge will improve this IoT in the sense all the drawbacks which we have stated will be. So, this will incur the low latency tight control loops near the real time responses with the help of, if you do the machine learning on the edge, then it can pre-process the data on the premise locally, that is the presence of the edge. It can perform the intelligence computation on the edge, and it will also perform the offline operation, even if let us say there is no connectivity or the connectivity broken between the edge and the cloud, even then it can work in a offline manner. And it will also protect the data privacy and IP protection. Why? Because the data will be there at the local site, not at the cloud. So, this will add into the data privacy to it. So, let us summarize. Let us summarize in this slide. What we have covered is that machine learning on the cloud in the traditional IoT system has a lot of disadvantages, thereby giving a way to perform the machine learning on the edge will brings in turns all the disadvantages into the advantages, and you can perform the inferencing or inside computation on the edge in the real time, and besides all other advantages which we have seen. Now, bringing the machine learning or performing the machine learning to the edge for IoT, let us understand the entire concepts, and we will see how the machine learning can happen at the edge. So, that means bringing the machine learning to the edge for performing the IoT application is the main theme. Let us understand that the cloud has this kind of capability that it can enable the edge. So, we call this particular functionality because these functionalities are often provided by an IoT platforms by different cloud providers for edge services. One such important service is called Azure IoT Hub. So, let us see that this particular cloud is running that, and this is let us say a Microsoft cloud called Azure, and this is running Azure IoT Hub service. So, you can see that Azure IoT Hub service is running as the cloud gateway. Now, this particular Azure IoT Hub has the functionality that either after receiving the IoT data, it can perform the insight computation and also compute the actions and then communicate it back the results to the IoT or to the Internet of Things. Now, what happens that if very close to the Internet of Things, if you provide an edge and this edge runs an Azure IoT edge runtime and enables to perform these actions, that is insight and actions there very close to the IoT the things, and they are called the edge. So, thereby bringing up that capabilities in the edge with the help of these particular cloud provider to perform all that whatever. So, it will save sending the data back to the cloud and perform all kind of insights and actions to be computed very close to the IoT device that is at the edge. So, let us understand this, that once the IoT device fetches the workload description from the cloud here, then whatever device receives his deployment manifest from the IoT Hub service, it understands that it should go fetch these containers, action and things over here. So, how that is all done, that we have explained here, that with the help of containers. So, if we containerize of computing the insights and actions, if we containerize these containers, we can deploy at the edge and thereby enabling this edge with this particular functionality of performing these insights and action computation like it was being done at the cloud. So, if we can, if the edge mimics the functionality of the cloud like services, then the edge can perform the functions such as insights and action computation on the edge. So, let us get more detail about this particular concept, and thereby it is called enabling intelligence at the edge layer. Now, to manage this increasing amount of data that is generated by the devices, sensors, most of the business logic is now applied at the edge instead of the cloud to achieve the low latency and have faster response time for IoT devices using the machine learning at the edge. So, this particular enabling is to be performed if the machine learning we can enable to be executed at the edge. Therefore, the edge layer is delivering three essential capabilities, that is local data processing, filtered data transfer to the cloud and faster decision making. So, let us see about the local data processing. So, in order to deal with the increasing amount of data which is generated by the sensors, so most of the business logic is now deployed at the edge layer and instead of the cloud to ensure the low latency and the faster response time. Now, only a subset of the data generated by the sensor is sent to the cloud after aggregating and filtering the data at the edge. So, this edge performing the intelligence computation at the edge will enable the local data processing, that is at the edge. Now, this will also have another advantage, that enabling intelligence at the edge for the IoT will make the faster decision making. So, AI has enabled the new capabilities for the edge computing, since most of the decision making is now taking the advantage of artificial intelligence. The edge layer is becoming the perfect destination for deploying machine learning models which are trained in the cloud. Let us see about the performance and the cost trade off in such IoT edge platforms. So, here the machine learning implementation at the edge heavily depends on specialized processors that complement the CPU, and there is no conventional CPU can increase the speed of the training machine learning models. Now, to bridge this particular gap between the cloud and the edge, the innovation in the chip design offers purpose built accelerator that speed up the inferencing significantly. So, the chip manufacturers like Qualcomm, NVIDIA and ARM have launched the specialized chip that speed up the execution of machine learning enabled application for the at the edge. Now, these modern GPUs assist the CPUs of the edge devices by taking over the complex mathematical calculation needed for running the deep learning model, accelerate the inferencing at the process. So, this results in the faster prediction, detection, classification of the data ingested to the edge layer. So, the solutions, like Azure IoT, Microsoft Azure IoT Edge runtime and the Qualcomm neural processing SDKs for machine learning makes it possible to make these models trained in the cloud, but run the hardware accelerated inferencing at the intelligence edge. Let us summarize. Now, the machine learning has two step process. Now, first thing is called when the data set and a machine learning algorithm, or when data set is presented to the machine learning algorithm, this particular process is called training the machine learning model. Once the model is trained, this particular model is deploy the trained ML model at the edge. Now, the other part which is called the inferencing. So, the inferencing can happen at the edge. So, the training at the cloud and the inferencing at the edge, and this is the machine learning process. It can be divided, the training can happen at the cloud and inferencing to happen at the edge, will enable these faster predictions. That is what we are now doing. So, machine learning pipeline has to have this following changes, that training can happen at the cloud, whereas the inferencing of the trained model can be deployed, and therefore, inferencing can happen at the edge. And for inferencing to have this good amount of speed, it requires accelerators for the edge is being developed by various companies like NVIDIA, then ARM and Qualcomm. Now, let us see the IoT data input to the machine learning model, that is whatever we have seen about the training and inferencing, that is the machine learning pipeline. We see that how it is going to affect for the IoT applications. Now, you see that the raw IoT data from IoT sensors, that is called IoT endpoints, is being generated, and now this particular IoT data is given for training. Now, for training, that is learning a new capabilities from the existing data, will require a deep learning or a machine learning algorithms, and also will have that part of the data which is used to train the model called training data set. So, the data set is now divided into two parts, training and inferencing. So, training data set will train this deep learning model using the data set which is stored here, whether it is on premise or the cloud hosted. Now, once the model is trained, this particular model is containerized and often deployed on the edge device. So, edge device or on premise or a cloud hosted, any of these capabilities, any of the functional, any of these particular placement can happen. Let us say that it is happening at the edge and it is happening at the cloud, that is the training is happening at the or the training is happening at the cloud, whereas the inferencing is happening at the edge. So, applying these capabilities to the new data is called inferencing. So, when a new data is presented to the trained model, it will be able to classify the service or it will get the insight of an IoT data. Let us understand about the training and inferencing separately. So, training involves the use of deep learning framework, often let us say that TensorFlow is one of the important deep learning framework, and the training data set. So, IoT data provides a source of training data that the data scientists and engineers can use to train the machine learning models for a variety of use cases and from failure detection to the consumer intelligence. Now, the second process of a machine learning is called inferencing. Inferencing refers to the process of using the trained machine learning model to make the predictions. So, when an IoT data can be used as the input to the trained machine learning model, will enable the prediction that can guide the decision logic on the device at the edge gateway or elsewhere in the IoT system. So, let us understand how to do the machine learning on the edge for IoT application. So, here first step is, let us say that we are using the cloud based service and this is called an IoT hub. So, IoT devices will send their data to the Azure cloud storage, and there using this particular data set which is stored in Azure storage service, then it will prepare and perform the experiment. For that, it will train the model using Azure machine learning algorithm, and using Jupyter notebook it will train the machine learning model. Once the model is trained in the cloud, so this is the cloud service, then this cloud service will deploy the trained model to the IoT edge. So, this is an IoT edge and this can deploy the trained model on. So, once the model is deployed, you can see that this particular model is running on an IoT edge. So, the third step is to run the model, that is to use the model on IoT edge and to predict the failure and pass the failure information to the cloud. Then fifth step is to maintain, that is to collect more training data, upload to the cloud periodically and improve the model over the time. So, here what kind of data which require to be sent to the cloud for retraining. So, this is a continuous process here, the model which is running a machine learning on an IoT edge. So, while we may touch many aspects of a general machine learning workflow, here in this lecture it is not intended to be in depth introduction of a machine learning. We intend to illustrate the process of creating a viable model for an IoT data processing at the edge. So, let us see all these steps in more details. So, the first step was to collect the training data. So, the process begins by collecting the training data. In some cases, data has already been collected and is available in the database. So, in other words, In other cases, especially for IoT scenario, the data need to be collected from IoT device and the sensors and stored in the Azure cloud, in the cloud, requires the cloud storage for data set. Second step here is to prepare the data and the experiment. So, to prepare and experiment, here in most cases the raw data as collected from the devices and sensors will require the preparation for the machine learning. This step may involve the data cleanup, data reformatting, pre-processing. To inject additional information, machine learning can key off. Third step is about the data preparation, which involves calculating explicit label for every data point in the sample based on the actual observation on the data. Finally, this information allows the machine learning algorithm to find correlation between the actual sensor data pattern and the expected results, and this step is highly domain specific. Examples are shown over here in for preparing and doing the experimentation, that is train the model using Azure machine learning, because the data set is available at the storage in the cloud, and this will be generating a machine learning model. Now, then how are we going to deploy the trained machine learning model in the cloud at the edge? So, based on the prepared data, we can experiment with different machine learning algorithms and parameterization, train the model and compare the result with the other model. In this case, for testing, we compare the predicted outcome by the model, and Azure machine learning this can be done in different iterations of the model that is created. So, here you can see that in the next step, it will deploy the trained model to the IoT edge. Now, finally, it will use the model on an IoT edge to make a predict the failure and pass the failure information to the cloud, that is shown over here. And fifth is that it will collect more training data, upload to the cloud periodically and improve the model over the time. Now, let us go in more detail about such an machine learning platform like Azure IoT Hub, how it does that, enabling machine learning at the edge platform. Now, this kind of service which most of the cloud provider provides for deploying the machine learning model to run at the edge, that is to do the inferencing at the edge, often is called software as a service or SaaS platform. So, IoT platform is nothing but a model under, it is a cloud model, that is software as a service. Let us understand this in more details. So, here you can see that this is an IoT device and this is an edge very close to the IoT device, and very far this is the cloud, where different type of IoT platform services are running. We call it as Azure IoT Hub is one such IoT platform services. So, Azure IoT Hub, which is nothing but an IoT platform which provides the service which is called software as a service, has the following module. The first module is called custom code, that is data transformation. The second is Azure cognitive service, which will do the insight computation. Third is called custom code, which provides the action. So, once the edge device is connected here, to the Azure IoT Hub service. Two custom modules now will be developed, one to capture the incoming data and send to the custom vision module, and another one to manage, control and get the score out of the display output of the model, and the last one is the custom vision model, which is used to provide the insight. Now, these particular modules are containerized. So, package the data transform, this one, insight is to be packaged and action is to be packaged into the container. This is called containerization of the application, IoT application. Now, once these modules, once they are containerized, now write these three modules and package them as a Docker container. Now, put the containers to the container registry and push all those Docker container into the container registry that we are now seeing here in this particular description. Now, once these containers are there in container registry in a Docker container, then write the deployment manifest, which is also called as a workload description, that deploy these modules on the edge. Now, target at the IoT edge, runtime on the edge device. So, here the IoT edge runtime will be deployed and it will be running on the edge. So, the edge device is running its runtime that appear because it is right hooked up to the specific instance of it. Now, the next step is to shift the workload description to the target IoT edge runtime on the edge. So, whenever the device receives this his deployment manifest from IoT Hub service, it understands that it should go fetch these three containers. So, all the three containers are now deployed. So, the target IoT edge runtime download the correct workload from the cloud and start them up using the container registry and run on edge devices. So, that is a workload that it will bring down from the cloud to the local edge. So, let us see about the Azure IoT Hub. Azure IoT Hub allows the bidirectional communication between the cloud and the IoT devices. So, this is an Azure IoT Hub. It allows the bidirectional communication between the cloud and IoT devices. It also allows the developer to take advantage of this information to provide insight, monitoring and develop the custom solutions for their IoT platform. So, let us see about the Azure IoT Hub key characteristics. So, it manages the service for bidirectional communication, is a managed service for bidirectional communication between the cloud and IoT devices. It is a platform as a service, that is, it is a platform as a service offering in the Azure cloud for IoT development. Then third important characteristics is that it is highly secure, scalable and reliable, that is, and service for the IoT devices. Fourth one is integrates with lots of Azure services, that is Azure cloud services. Next one is it is having programmable software development kit, that is SDKs for popular languages. And finally, the key characteristic is that supports multiple protocol, it supports for multiple common standard protocols when it comes to the communication protocols. Now, let us see about one such service or the application, which is called camera capture module. Handles scanning the item using the camera. It then calls the image classification module to identify the item, calls it then made to text to speech and the module to convert the item label to the speech and the name of the item can be scanned scan displayed on the attached speaker. Another one is called image classification module, runs a TensorFlow machine learning model that has been trained with the images of the fruit and classifies the scanned images. Text to speech module, and all of them requires an USB camera is used to capture the images, speaker for text to speech playback. So, here you can see that it will be done through the Azure IoT hub. It is also having the Azure speech services, Azure custom build services, and using that it can build different projects such as fruit model for image classification. So, this particular type of services which is offered by IoT Edge we have already explained. Now, Azure IoT Edge in action. So, develop your container workloads and upload the module to a container registry, provision IoT Edge device agents and select the device deployment, and define the modules, define the message routes, define the module parameters. So, let us see about the Azure IoT Edge functionalities. So, for the target workloads, add the correct type of devices, create the workload that can include a high value machine learning and run those workloads locally in a disconnected manner, and then monitor the health of the workloads. So, let us see about the advantage of edge machine learning. So, it will be having the reduced latency, that is the transfer of data back and forth from the cloud takes time. So, edge machine learning reduces the latency by processing the data locally. Real time analytics is a major advantage of edge computing. So, edge machine learning brings high performance computing capabilities to the edge where sensors and IoT are located. Higher speed, that is data is processed locally with which significantly improves processing speed as compared to the cloud. Reduced bandwidth requirement, that is edge machine learning processes data locally on the device itself, reducing the cost of internet bandwidth and the cloud storage. Improved data security, that is edge machine learning systems perform the majority of the data processing locally on the edge itself. This greatly reduces the amount of data which is to be sent to the cloud and other external locations. It will improve the scalability, it will improve the reliability, it will reduce the cost and reduce the power. Therefore, performing the machine learning at the edge has a lot of advantages that we have so far seen. Applications of performing the machine learning at the edge has its applications in manufacturing, energy sector, that is oil and gas, industrial internet of things, autonomous vehicles, healthcare, smart homes. Now, let us see about the edge with the cloud. So, edge computing emerges as an attractive alternative, especially to the host computation task to be done as close as possible to the data sources and users. Certainly, the edge computing and cloud computing are not mutually exclusive, instead the edge complements and extends the cloud, that we have seen in the previous slides. Compared with the cloud computing, only the main advantage of the edge computing combined with the cloud computing are 3. So, that means edge computing will have this backbone network alleviation, that is not every data is to be now sent to the cloud and thereby alleviating the traffic load on the network. The other important advantage is the agile service response, that is the services hosted at the edge can significantly reduce the delay of data transmission and improve the response speeds. Powerful cloud backup, that is the cloud can provide the powerful processing capabilities and massive storage which when edge cannot afford. Now, let us see about what to mean by the intelligence at the edge. So, the edge intelligence which we have seen in the previous slide, that is edge intelligence is expected to push the deep learning and machine learning computations from the cloud to the edge as much as possible, and thus enabling various distributed low latency and reliable intelligent applications and services. The advantage which we have seen is the reduced latency and enhanced security. What do we mean by reduced latency? That machine learning services are deployed close to the requesting users, hence significantly reducing the latency and the cost of sending data to the cloud for processing. Enhanced security means the raw data required for machine learning is stored locally on the edge or the user devices themselves instead of sending it to the cloud, thereby data protection of the user privacy is often enhanced. So, here you can see that we are talking about the edge intelligence that is enabling applications to run the intelligence at the edge. To run machine learning at the edge. So, this is called the edge intelligence. Now, the other part is called intelligent edge. So, intelligent edge aims to incorporate machine learning into the edge for dynamic adaptive edge maintenance and management. So, the maintenance and management of a large and complex overall architecture involves wireless communication, networking, computing, storage is often a major challenge, and therefore, machine learning is expected to deal with this particular problem. One faced with the complex and cumbersome network information, machine learning can rely on a powerful learning and reasonable ability to extract the valuable information from the data and make adaptive decisions, achieving the intelligence, maintenance and management accordingly. So, here you can see that in this ecosystem, that is an edge cloud system which often uses lot of communication technologies at every stage, requires the intervention of intelligence, thereby running the edge is requires lot of intelligence. So, it is called the intelligence edge. So, intelligence using the intelligence computation, it can achieve the intelligent maintenance and management, and thereby it is called the intelligent edge. Now, the machine learning at the edge, inferencing the machine learning models require the support of high level hardware, and it is difficult to deploy in the edge with a limited resource. Therefore, large scale machine learning models are generally deployed in the cloud, trained in the cloud, while the end devices just send the input data to the cloud and wait for the inference results, which can happen at the edge. So, the cloud only inference limits the ubiquitous deployment of deep learning services, specifically it can not guarantee the delay requirements of real time services, real time detection with strict latency demands. Moreover, for important data sources, data safety, privacy should be addressed, hence deep learning services tend to resort to the edge computing. So, deep learning models should further be customized to fit into the resource constrained edge, while carefully treating the trade off between inferencing accuracy and execution latency of them. Now, let us see about the optimization of deep learning models at the edge requires these following intervention, that is parameter pruning, quantization, low rank factorization and knowledge distillation. So, deep learning tasks are usually computationally intensive and requires lot of memory, large memory footprint, but in the edge there are not enough resources to support the large scale deep learning models. So, optimizing these deep learning model and quantize their weights can reduce the cost. So, model redundancies are common in deep neural network, can be utilized to make the model optimizations. So, the most important challenge is how to ensure there is no significant loss in the model accuracy being optimized. So, optimization approach should transform or redesign the deep learning model and make them fit in the edge devices with little loss of the model performance. So, therefore, we are going to see that this can be achieved with the help of parameter pruning. So, here you can reduce the size of the model by removing some of the parameters or the weights. The second one is quantization, that is the deep learning often uses the single precision floating point data types and to store the weights and activation that can reduce the memory requirement of the network. Third important aspect is called low rank factorization. Low rank factorization is to approximate the weight matrices of the neural network using low rank matrices, and low rank matrices approximates the weight matrix as the product of two low rank matrices, and this reduces the number of parameters required to represent the weight matrix. Knowledge distillation is a technique used in the neural network to transfer the knowledge from large complex to a smaller simpler model. Segmentation of deep learning model at the edge. Now, based on the delay and power consumption, some advanced deep learning models were evaluated on the cloud and edge, finding that uploading data to the cloud is bottleneck. So, therefore, here the measures have been taken to improve the end to end performance and latency by involving the segmentation. So, segmentation of a deep learning model horizontally along the edge, along the end edge and cloud is most common segmentation method. So, segmentation methods in the edge is shown here in very brief manner how this can be done. How the virtualization can be done. Virtualizing the edge means that the resources of the edge computing is limited and the edge computing cannot provide the resources that machine learning services as the cloud, but virtualization helps to maximize the resource utilization under the constraint of a limited resources. So, virtualizing the edge is also shown over here. So, various virtualization techniques which are used here such as virtual machine and container. It also requires the network virtualization, network slicing and distributed deep learning training and collaborative edge training. So, what we have now distinguished between AI for the edge and AI on the edge here, which is shown over here to have a better quality of service, quality of experience, that is QoE. So, the factors which are affecting the quality of service can be achieved using two measures. One is called AI for the edge, which is nothing but has three different important aspects. One is called topology, the other is called content and services. So, topology is that edge orchestration and coordination with the small base station, content and the service computation. So, AI for the edge has lot of challenges in terms of model establishment, restraining the optimization model such as stochastic gradient descent and mini batch gradient descent use in that particular model establishment. Algorithm development and trade off between optimality. Similarly, AI on the edge requires data availability, model selection, coordination mechanism, and it all requires a proper AI life cycle end to end automation, which is shown over here, and managing the AI life cycle is also shown over here. So, AI operation workflow requires cloud to cloud, cloud to edge, edge to cloud, edge to edge, and this is all summarized here in this particular table, and this will facilitate the complex edge AI. So, conclusion, what we have seen is that AI for the edge and AI on the edge and we have seen how the machine learning can be run at the edge. All these discussion we have seen in this perspective. So, what we have seen is how the AI on the edge and AI for the edge, and both of them requires the intervention both the ends, that is AI for the edge, that is requires how the infrastructure can be automated. AI on the edge will require the intervention running the AI on the edge for supporting different applications. So, we will see more details in the further lectures. Thank you.